When supplying power to a detached building, understanding the grounding requirements is critical for safety. There are two primary scenarios to consider. Firstly, when you run an equipment grounding conductor, also known as an EGC, with your feeder conductors consisting of hot wires and neutral wire, and the separate equipment grounding conductor, a ground rod is not required at the detached building. The equipment grounding conductor provides a dedicated path for fault currents to return to the main service panel in the main building, where the overcurrent protection devices are located, such as circuit breakers, effectively clearing the fault. Secondly, if you choose not to run an equipment grounding conductor to the detached building, then a ground rod or ground rods are required at the detached structure. This ensures that the electrical system within the detached building has a local path to ground in the event of a fault. Now let's look at the aspect of neutral bonding. When you do not run an equipment grounding conductor to the detached building and instead rely on a ground rod, the neutral conductor of the detached building must remain isolated from the ground rod. This means that the neutral should not be connected to the ground rod or any other grounding electrodes at the detached building. The purpose of this isolation is to prevent circulating ground currents, which can create electrical noise and potentially pose a safety hazard. Conversely, if you do run an equipment grounding conductor with your feeder to the detached building, the neutral conductor should be bonded to the grounding electrode system, typically a ground rod, at the main service panel in the main building. This creates a common grounding reference for all electrical systems, ensuring that fault currents have a clear path back to the source. To summarize the requirements, firstly, if you run an equipment grounding conductor with your feeder to the detached building, you do not need to install a ground rod at the detached building, and the neutral conductor remains isolated at the detached building's panel. Secondly, if you do not run an equipment grounding conductor with your feeder to the detached building, you must install a ground rod or grounding electrode system at the detached building, and the neutral conductor at the detached building's panel remains isolated from the ground rod. It is imperative to always consult with the latest edition of the National Electrical Code, also known as the NEC, and local electrical codes for specific requirements and interpretations in the specific area, as codes may vary slightly depending on the jurisdiction. The NEC provides detailed guidelines on grounding and bonding to ensure electrical safety. Some additional considerations include, firstly, the size of the equipment grounding conductor must be properly sized according to NEC Table 250.122, which dictates the minimum size of the equipment grounding conductor based on the size of the overcurrent protection device protecting the feeder conductors. Secondly, the ground rod used should meet the requirements outlined in NEC Section 250.52, which specifies the types of grounding electrodes that are permitted, such as ground rods, ground plates, and concrete encased electrodes, often called UFERs. Thirdly, when driving ground rods, ensure that they are installed deep enough into the earth to make good contact with the soil, and that the connection between the ground rod and the grounding conductor is made with approved connectors. Fourthly, consider the soil conditions in the specific area, as soil resistivity can affect the effectiveness of the grounding system. In areas with high soil resistivity, multiple ground rods may be required to achieve the desired grounding impedance. Fifthly, regularly inspect the grounding system to ensure that all connections are tight and free from corrosion. Corrosion can degrade the performance of the grounding system and compromise electrical safety. Lastly, if there are any metallic water pipes entering the detached building, they should be bonded to the grounding electrode system to ensure that they are at the same electrical potential as the rest of the grounding system. This helps to prevent electrical shock hazards. Remember that proper grounding and bonding are essential for electrical safety. If you're unsure about any aspect of the grounding requirements, always consult with a qualified electrician. Furthermore, it's crucial to understand the difference between grounding and bonding. Grounding refers to connecting electrical equipment to the earth, providing a path for fault currents to flow back to the source. Bonding, on the other hand, refers to connecting different metallic parts of the electrical system together to create a low impedance path for fault currents. Both grounding and bonding are necessary for electrical safety. Now, let's delve into some specific code references. NEC Section 250.32 covers grounding requirements for detached buildings or structures. It specifies the conditions under which a grounding electrode system is required at the detached building. NEC Section 250.50 covers the grounding electrode system, which includes all of the grounding electrodes that are present at the building, such as ground rods, ground plates, and metal water pipes. NEC Section 250.52 specifies the types of grounding electrodes that are permitted by the code. NEC Section 250.64 covers the grounding electrode conductor, which is the conductor that connects the grounding electrode to the electrical system. It specifies the size and installation requirements for the grounding electrode conductor. NEC Section 250.122 covers the equipment grounding conductor, which is the conductor that connects the metallic parts of the electrical system to the grounding electrode system. It specifies the size and installation requirements for the equipment grounding conductor. When dealing with multiple buildings, it is also important to consider NEC Section 250.30, which covers grounding requirements for separately derived systems. A separately derived system is an electrical system that is not directly connected to the utility power source, such as a generator or a transformer. In addition to the NEC, there may be local electrical codes that apply in the specific area. It is important to consult with the local authority having jurisdiction, often referred to as the AHJ, to determine what local codes are in effect. The AHJ can provide guidance on specific grounding requirements and interpretations in the specific area. Some common grounding mistakes to avoid include, firstly, using undersized grounding conductors. The grounding conductors must be sized according to the NEC to ensure that they can safely carry fault current. Secondly, making improper connections. Grounding connections must be made with approved connectors and must be properly tightened to ensure a low impedance path for fault currents. Thirdly, neglecting to bond metallic water pipes. Metallic water pipes that enter the building must be bonded to the grounding electrode system to prevent electrical shock hazards. Fourthly, failing to inspect the grounding system regularly. The grounding system should be inspected regularly to ensure that all connections are tight and free from corrosion. Fifthly, ignoring local code requirements. Local electrical codes may have additional grounding requirements that must be followed. In summary, grounding and bonding are critical for electrical safety in detached buildings. By following the requirements of the NEC and local electrical codes, you can ensure that the electrical system is properly grounded and bonded, protecting people and property from electrical hazards. Always consult with a qualified electrician if you have any questions or concerns about grounding and bonding requirements. Remember, electricity can be dangerous, and it is important to take all necessary precautions to ensure electrical safety. In addition to the technical aspects, it is also important to consider the human element. Make sure that everyone who works with electricity is properly trained and qualified. Provide regular safety training to ensure that everyone is aware of the hazards of electricity and how to work safely. Encourage a culture of safety in the workplace, where everyone is empowered to speak up if they see something that is unsafe. By combining technical knowledge with a strong safety culture, you can create a safe and reliable electrical system in the detached building. Now let's address some frequently asked questions about grounding detached buildings. Firstly, what is the purpose of grounding a detached building? The purpose of grounding a detached building is to provide a path for fault currents to flow back to the source, protecting people and property from electrical shock hazards. Secondly, what is the difference between grounding and bonding? Grounding refers to connecting electrical equipment to the earth, while bonding refers to connecting different metallic parts of the electrical system together. Thirdly, do I need to install a ground rod at a detached building? The requirement for a ground rod depends on whether you run an equipment grounding conductor to the detached building. If you do not run an equipment grounding conductor, you must install a ground rod. Fourthly, can I use the same ground rod for multiple buildings? No, each building must have its own grounding electrode system. Fifthly, how do I test the effectiveness of a grounding system? The effectiveness of a grounding system can be tested using a ground resistance tester. This device measures the resistance between the grounding electrode and the earth. Sixthly, what should I do if I suspect that my grounding system is not working properly? If you suspect that your grounding system is not working properly, contact a qualified electrician to inspect the system and make any necessary repairs. Remember, electrical safety is paramount. Always take the time to understand the grounding requirements for detached buildings and follow all applicable codes and regulations. By doing so, you can help to ensure a safe and reliable electrical system.